Sierra, what is the title of our lesson today?
11.2
And what can you now do, Sierra?
I can use tree diagrams to represent outcomes.
And besides tree diagrams, what else can you use to represent outcomes, Sierra? Okay, not sample space. What is that thing we just learned at the very end, Elsa? So we can use tree diagrams and the fundamental counting principle to determine outcomes of various situations. So a tree diagram is a visual, outcome is a result, and a sample space would be all of the results in one. Okay? When we scroll down our notes here, and we're looking at tree diagrams, you have an example of Lily tossing a coin, and we give you the scenario, what would be the total number of outcomes or the sample space if she tossed a coin, Julia? Twice. So she tossed it once, she just picked it up and tossed it again. What are all the possible outcomes? You see how we created that tree map. Right, Kaya? Katie loves ice cream, don't you, Katie? And she loves 4 different flavors and 2 different types of ice cream cones. We created a tree diagram, a couple of different tree diagrams. Here's one example of a tree diagram to determine all of the different types of flavors that go with the different kinds of cones that Katie likes. And then we had another group come up and do the same thing with a little bit of a different tree diagram. Okay, and we got 8 outcomes. Julia loves socks. We had Julia drawing socks out of her drawer, then putting the sock back and drawing again. And we figured out all the different combinations that Julia could use or could draw when picking socks. And then we actually did some math. What is the probability she'll draw a blue sock? What is the probability she'll draw a sock of the same color? And what is the probability she'll draw a sock that is not rainbow in color? Okay, so far so good? And the very last thing we learned is the fundamental counting principle, which states you take the first set of choices, you multiply it by the second set of choices, you multiply it by the third set of choices, you multiply it by the fourth set of choices. The product of all of those choices would be your total number of outcomes. So for example, we're going to do one right now in our notes. If I went to college, remember my college example, and I had a choice of 5 appetizers, and I had a choice of 3 entrees, and I had a choice of 2 desserts, how many different combinations would I have to choose from every single time I went to lunch or dinner at my college? Because that is what we had. 5 appetizers to choose from, 3 entrees, and 2 desserts. So every day I went to lunch, I had how many different ways of putting my dinner or my lunch together every day I went to lunch or dinner? Aiden.
30 outcomes.
5 times 3
30
times
choices.
2, I would have 30 different
Choices.
right? Now, if I said, give me the probability that I would have chocolate pie with one of my choices, would you need to create a tree diagram?
Yeah.
Yes. Did I ask for the probability of a chocolate pie in this particular instance? No, so would the fundamental counting principle be okay? Good. Any questions?